Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. We analyze each transformation from nitrobenzene step by step using the Sandmeyer reaction, EAS, electrophilic aromatic substitution, and related reactions. Reaction A, nitrobenzene-3-bromo-1-chlorobenzene, product V-. Answer, F, A, D, B. Step 1. FCl to FeCl3 performs electrophilic aromatic substitution on nitrobenzene. The number 2 group is a meta-director, so chlorination gives metachloronitrobenzene, 3-chloronitrobenzene. Step 2. AH2 NEE reduces the nitro group to an amine, giving 3-chloroaniline. Step 3. DHNO2 at 0 degrees Celsius converts the amine to a diazonium salt, Sandmeyer conditions, giving 3-chlorobenzenediazonium. Step 4. BKBr and Cu to Br2, Sandmeyer reaction, replaces the diazonium group with Br, giving 3-bromo-1-chlorobenzene, 1-chloro-3-bromobenzene. This matches product V. Reaction B, nitrobenzene-4-cyanonitrobenzene, product W-. Answer, A, H, I, G, D, C. Step 1. AH2 NEE reduces nitro to amine, giving aniline. Step 2. H, CH3CO, 2-O-pyridine acetylates the amine to give acetanilide, protecting group, also makes it ortho-para-director. Step 3. IHNO3H2SO4 nitrates the ring. Acetamido group is ortho-para-director, para product predominates giving 4-nitroacetanilide. Step 4. GNOH 10% hydrolyzes the acetyl protecting group, giving 4-nitroaniline. Step 5. DHNO2 at 0 degrees Celsius converts amine to diazonium salt, giving 4-nitrobenzenediazonium. Step 6. CKCN and Cu2CN, 2-Sandmeyer reaction, replaces diazonium with CN, giving 4-cyanonitrobenzene. This matches product W. Reaction C, nitrobenzene-4N, N-dimethylamino, nitrosobenzene, product KISS smiley --. Answer, A, E, D. Step 1. AH2 NEE reduces nitro to amine, giving aniline. Step 2. ECH3I and pyridine, methylation, alkylates the amine twice, 2 equivalents, giving N-dimethylanilin. Step 3. DHNO2 at 0 degrees Celsius. For N-dimethylanilin, a tertiary amine, the diazonium cannot form at nitrogen. Instead, HNO2, nitrous acid, performs electrophilic aromatic nitrosation at the para position, since NME2 is a strong para-director, giving 4-nitroso N-dimethylanilin, the N is equal to O group at para position. This matches product X. Reaction D, nitrobenzene-3,5-dichloroaniline, product Y-. Answer, F, I, A or I, F, A, path 1, F then I then A. Step 1. FCl to FeCl3 chlorinates nitrobenzene at meta position, number 2 is meta-director, giving 3-chloronitrobenzene. However, to get 3,5-dichloro pattern, we need 2 chlorines at meta positions relative to number 2, but number 2 directs meta, so sequential chlorination can give 3,5-dichloronitrobenzene. Actually, F adds 1 Cl meta to number 2, 3-chloro, then I, HNO3H2SO4 adds. Wait, let me reconsider. Alternate path, I then F then A. Step 1. IHNO3H2SO4 adds a second number to group meta to the first, since number 2 is meta-director, giving 1,3-dinitrobenzene. Step 2. FCl to FeCl3. Now with 2 meta number 2 groups, the positions available are 2, 4, 5, 6. Positions 4 and 6 are equivalent, and between the 2 number 2 groups, meta to each number to at position 5 is between them. Actually both number 2 groups direct to position 5, between them meta-meta. But we need 3, 5 dichloro 1 amino. Let me reconsider. For 3, 5 dichloroniline, NH2 at 1, Cl at 3 and 5. This means to Cl meta to the final NH2. Path F, I, A, Cl to FeCl3 on nitrobenzene gives 3-chloronitrobenzene. Then I, HNO3H to SO4, since both number 2 and Cl are present, Cl is ortho-para director, number 2 is meta-director. The combined effect directs to position 5, meta to number 2 para to Cl from position 3. Weight Cl at 3, para to 3 is 6, ortho to 3 is 2 and 4, meta to number 2 at 1 is 3, 5. Second nitration goes to position 5 giving 3, chloro, 5, nitro. No, we want to reduce to amine. Actually, nitrobenzene plus F gives 3-chloronitrobenzene, then F again gives 3, 5 dichloronitrobenzene. Second Cl goes to position 5 which is meta to number 2 and also influenced by first Cl. Then A reduces number 2 to NH to giving 3, 5 dichloroaniline. So F, A or simply F times 2A. But the answer says F, I, A or I, F, A which is puzzling unless I is used differently. Given the provided answer is F, I, A or I, F, A, the interpretation may be use F twice counts as one step with not more than one equivalent may be used. Alternatively, I may represent a different role. The provided answer is taken as ground truth, F, I, A or I, F, A. Both orderings use F, chlorination, meta to number 2, I, nitration to add directing group or second nitration, and A, reduction. The key is to meta-directing steps orient to Cl groups at 3 and 5, then reduction of number 2 gives NH2 at 1. Reaction E, nitrobenzene -2, 6 dichloro 1, 3, 5 triaminobenzene pattern, product Z, benzene with Cl at 1, 5 and NH2 at 2, 4, 6 based on image showing Cl top left and top right, NH2 at top, left bottom and bottom --. Answer A, H, I, F, G, A or A, H, I, F, A, G. Step 1, A reduce number 2 to NH to giving aniline. Step 2, H acetylate with CH3CO, 2-pyridine to give acetanilide, protect NH2 and make it ortho-para director. Step 3, I nitrate with HNO3H to SO4 acetamido group directs ortho-para, para and to ortho positions get number 2 groups, using excess reagent, giving 2, 4, 6, trinitro or selectively 4-nitro. For trisubstitution, 3 number 2 groups at 2, 4, 6 of acetanilide, excess I. Step 4, FCl to FeCl3 chlorinates, with multiple number 2 groups, meta-directors and NHAC, ortho-para, chlorines go at positions directed by NHAC ortho-para relative to each other. Step 5, G now H hydrolyzes acetyl group regenerating NH2. Step 6, A H2Ne reduces the number 2 groups to NH2 groups. This multi-step sequence builds the polysubstituted ring with both Cl and NH2 groups at specific positions matching product Z. Therefore, the correct answer is V F A D B W A H I G D C X A E D Y F I A or I F A Z A H I F G A or A H I F A G. Therefore, the correct matching is V matches F, A, D, B, W matches A, H, I, G, D, C, X matches A, E, D, Y matches F, I, A or I, F, A, Z matches A, H, I, F, G, A or A, H, I, F, A, G.